Start now, start. Good morning, sir.
Good morning. Good morning. Good morning.
Good afternoon.
Yeah.
I welcome Mr. Joseph Mathew, Managing Director, Insta Technologies, Coimbatore. Today, he handled the session 8, different 3D printing technology, part 1. And also, I introduced Mr. Joseph Mathew, sir. He is a master degree holder, and also he did bachelor degree in 2009 to 2013 mechanical engineering, and also having a university rank holder, and master of engineering completed from 2013 to 2015 in the discipline of advanced manufacturing technology, and also he is a university rank holder. Currently he is a managing director, Insta 3D Technologies, Coimbatore. And also, he was worked as assistant professor from 2015 to 2016 at Karpagam College of Engineering, Coimbatore. And also worked with projects from 2014 to 15, Board India Private Limited, India Piston Rings. So now it's to hand over the session, Mr. Joseph Mathew, sir. Thank you. Once again, I warm welcome to hand over the session. Thank you, sir.
Thank you. Thank you, Maniza.
Thank you,
So
sir.
let's start the session now.
Yes, sir.
Stop, sir.
So it's visible, right, sir?
Yes, sir.
Yeah. Okay, sir. Yeah. So first of all, I would like to thank KSR Institute for Engineering and Technology, Department of Mechanical Engineering, for inviting me to this online FDP, 3D printing and design. So my topic for today's session is different 3D printing technologies. First, let's get into the manufacturing processes available. Barely it's classified into two types. One is additive manufacturing, the other one is subtractive manufacturing, which is a basic manufacturing process. So, what is subtractive manufacturing process? So, in this, a raw material is available, and from the available raw material, the material is subtracted, and the final product, end product, is evolved from the raw material. For example, in a milling machine, this shows a wood milling characteristic. So this is a wood milling machine where the tool is used to remove the material and form the final object. Here, the wastage occurring is very high. Whereas in additive manufacturing, this refers to a process by which the design data is used to build up the component in layers by depositing material one above the other. So in additive manufacturing, the layer is deposited one layer by one layer above each other. So as you see, the difference between the subtractive process and the additive manufacturing process. So in conventional manufacturing, that is subtractive process, the material is machined and the end product is formed. You'll have huge amount of scrap or waste, which is
Sir,
very
your PPT is not visible, sir. Sorry to interrupt you. Your PPT is not
sorry, yeah,
visible.
it's not visible. Okay,
Sir.
is it okay now? Is it okay now?
Yes, sir.
Sir,
No,
visible,
still
sir.
not.
Just a second, just
Now
a
it's
second. Yeah, it got paused away. Yeah. Is it okay right now?
Yes,
Yes, sir.
it's
Now visible.
visible now.
Yeah.
Yes, sir, it's visible.
So in subtractive manufacturing process, the scrap and waste involved is very high, whereas in additive manufacturing process, the material is deposited layer by layer and hence reducing the scrap or waste. So this is the main difference between subtractive and additive manufacturing process, which is very well known to us. So let's start with 2D printing. You know, 2D printing is the process of converting a digital file into a 2D object, that is digital to physical object in 2D format. So what is 3D printing? So this is also a digital transformation of from a digital file into a physical object. This is a pile up of 2D images which forms the 3D object. So this is a chess coin which is shown in the left side. It shows the digital format file, and in the right side the 3D printer prints it in layer by layer to form the final object. So you understand what is 3D printing. Let's talk it technical wise. So 3D printing is basically known as rapid prototyping, and it is the automatic construction of physical objects using additive manufacturing technology. So there are other terms related to the rapid prototyping technology. One is solid freeform fabrication, digital fabrication, automated freeform fabrication, and many other names are available for 3D printing technology. So commonly it's called as, technically in academic side it's called rapid prototyping, and in the commercial part it's called 3D printing. So coming to the topic, there are different types of 3D printing technologies, which is differentiated based on different building mechanisms, different price points, different materials used, different applications. So let's see one by one. So the first one is material extrusion technique, that is the FDM, which is called fused deposition modeling. FDM is called fused deposition modeling, or it is also named as fused filament fabrication, that is triple F, fused filament fabrication. So this FDM is an additive manufacturing process that belongs to the material extrusion family. In FDM, an object is built by selectively depositing melted material in a predetermined path layer by layer. The materials used are thermoplastic polymers and comes in the format of filament. So this FDM 3D printing technology is the most widely used 3D printing technology. It has a wide range of 3D printers established globally, and it is one of the best technology which people are exposed to very much. So in this FDM technology, a designer should keep in mind the capabilities and limitations of the technology when fabricating a part, as this will help him achieve a best or the desired result. So let's see the FDM manufacturing process. As you see in the image, there is a print head. This is the print head, and the material is being inputted into the print head, and which this is the build platform, and the material is injected through the nozzle and it builds layer by layer and hence forming the final object. These straight lines are called support materials, which will be discussed in the later slides. This is an image of the 3D printed FDM 3D printed object. So let's come into the FDM process. How does a FDM work? A spool of thermoplastic filament is first loaded into the printer. Once the nozzle, this is the nozzle, extruder nozzle, once the nozzle is heated and has reached the desired temperature, the filament is fed to the extrusion head and in the nozzle where it melts. So this filament here, this is the spool which is the filament. This is a thermoplastic material and it is fed into the nozzle through drive wheels. The motor drives the filament into the nozzle, where the nozzle hotend melts the 3D printing filament, and then it starts depositing layer by layer. So this extrusion head is attached to a 3-axis system, which allows it to move in X, Y, and Z directions. The melted material is then extruded in thin strands and is deposited layer by layer in predetermined locations where the X and Y or Z axis moves. Sometimes cooling of the material is accelerated using cooling fans, which is attached to the extrusion nozzles to cool the parts. So in this working principle, you can see a platform which is moving downwards, and the nozzle head is moving in the X and Y direction. So there are two materials used. One is the build material and the other one is the support material. So when you see, you can ask us like, what is the support material? So this support material is used to um, build the actual part. So if there are overhangs in the actual part, like above 45-degree, the part here mentioned in the blue color has a overhang, and so the part support structures are being developed. So this support material is fed into one nozzle, and the build material is fed into another nozzle. So the part and the support structures are getting generated in the 3D printer. Once the part is finished, completely 3D printed, these support materials can be removed either by breaking away or by dipping it into hot water. So there are basically two types of support material. One is breakaway support structures, and the other one is water soluble support structures. So in this FDM technology, you can use either a single nozzle or dual nozzle. So the one shown here is the dual nozzle setup. So one carries the build material and the other one carries the support material. If this has a single material, in the case of single material, it has a breakaway support structures. So the support structures can easily be broken away. So let's get into the parameters used in FDM technology. This FDM technology has different parameters such as layer height, infill ratio, shells, infill pattern, etc. So these parameters can be adjusted in the 3D printing software according to the product which we are going to manufacture. So the layer height can be varied from around 50 microns to 600 microns or even 1 mm. So the layer height can be varied drastically based on the nozzle size available. So in this, the extrusion nozzles are very small, that the extruded material will be about equal of the nozzle size. If the nozzle size is 0.4 mm, the output extrusion material will be also 0.4 or 0.38 mm. So the layer height achievable in a 0.4 mm nozzle will be around 200 microns to 300 microns. It's the best layer height, which it's also called layer resolution. So it is the best layer height or layer resolution which is obtained in a FDM 3D printer. So the infill ratio, shells, and infill pattern, which can be shown in the 3D printing software. So
Sir,
this is
can you please share the screen?
yeah, just a second. When I come out, it's getting paused, I guess. Is it okay now?
Yes, sir. Thank you.
Yeah. So this is a 3D digital file, and this is a 3D printer machine, and this software's name is Idea Maker. This is used to convert the digital file, that is the STL file, into a G code, machine coded language. So here, when I go for 3D printing, I just slice the component, and when I start slicing, you can vary the infill density shells. So the infill density I'm giving it as 25%. The shells, if I need it to be very strong, I will give it as 3 shell. and the supports are enabled, and it has only one nozzle. Assume that the 3D printer has only one nozzle. Okay. So when I go for the advanced settings, there is infill pattern type where I can keep it as honeycomb structure. So this is the best infill pattern which is available in the software. So I'll just slice it so that you can see the preview of the component. So now you can see the preview of the component. It is placed in a different orientation, like in a vertical orientation, which is not actually doable. This should be placed in the flat orientation that I'll be showing you. So I'll explain the different structures in this. So in this blue one is the support material. So the first layer is this, and hence it forms the depositing different layers, it forms the final object. Since there is a overhang here, this is the overhang here, so this support material is formed beneath it, and this support material can be broken away easily after the 3D printing is finished. So coming into the part orientation, you can rotate the component in any manner, like you can place it in this way or in this way. So both are doable, and if you place it in X direction, so this will have a good strength when compared to the previous one. So the parts should be laid flat in order to get a higher strength. When the Z height is higher, the part strength reduces. So this is a main important characteristic of 3D printing technology. So this is how FDM works. So next is warping. So warping is one of the most common defect in FDM. When the extruded material cools during solidification, its dimensions decrease actually. As different sections of the print cool at different rates, their dimensions also change at different speeds. So differential cooling causes buildup of internal stress and pull up the underlying previous layer. So the warping occurs. So it is like the second layer when printed on the first layer, the second layer when it cools, it pulls the first layer upwards. So warping of material can happen, which is a defect in FDM technology. So the choice of the designer should be like large and flat areas should be avoided. Then thin protruding features like some extrusions or some protrusions should be avoided in order to avoid warping. And sharp corners should be avoided, and instead of sharp corners you can give fillets to avoid the warping problem. So there are different materials available in FDM technology, right from the commercial materials to high performance materials, starting from PLA, ABS, HIPS, PVC, TPU, PETG, PEEK. These are all the materials which is available in the market, and each material has different properties which differ based on the application. So basically everyone will be using PLA material and ABS material in a FDM 3D printer. These are all thermoplastic materials which can regain their shape once deformed, and like it can form any shape and can be reused as well. So when you're going for PLA, it has excellent visual quality, it's easy to print with, and has very low impact strength, which is a disadvantage of PLA. In ABS, which is a commodity based filament, so in this it is a good strength material. It has good temperature resistance when compared with PLA, but it has more warping characteristic. So when printing with ABS, this total machine should be in an enclosed manner so that the final output is perfect. Without warping, without any defect, the printed object can be taken out. So let's see the benefits and limitations of FDM technology. So this FDM technology is the most cost-effective method of producing customized thermoplastic parts and prototypes. In the market, everyone will be using FDM technology when compared with SLA and other techniques. This FDM technology has a shorter lead time. Like when you give a 3D printed part today, you can get the 3D printed part the same day or the next day, because the technology availability is very high and it's available almost everywhere. Even low cost machines starting from 20,000 is available for FDM technology. And the material availability is also very high in FDM technology. So hardly the PLA or ABS material which is used in the FDM has it comes around only 1,000 or 1,500 Indian rupees. So it's more beneficial than the other printing technologies in terms of commercialized product. So the limitations in FDM is it has low dimensional accuracy and the resolution is very low when compared with other 3D printing technologies. So it is not suitable for parts with intricate details. The parts with intricate details should not be 3D printed with and should not be printed with the FDM technology. And the other limitation is disadvantage is it has visible layer lines, so that some kind of post processing is very much required to finish the FDM printed component. So this post processing technique, coming to the post processing technique, you can use various methods to coat the FDM printed component. One is epoxy coating. You can mix the epoxy material and start coating the FDM technology and use the fine grit sandpaper to finish the component. Or you can use the normal acrylic paint to coat over the FDM 3D printed component. Even nowadays, home electroplating process is done for FDM plastic parts, where metal plating is done over the plastic components. So it is also available nowadays, which is done by many hobbyists. You can just search the internet or YouTube for metal plating of FDM 3D printed parts, which will be very much useful for carrying out many research in this area. So next technique is the VAT polymerization, or is called the SLA or DLP or SLA LCD technique. So SLA, it is called stereolithographic apparatus, whereas DLP is called digital light processing. So combining these two technologies is the one called SLA LCD technique. So we are going to look at what is SLA and DLP technology. So this is a SLA 3D printed part in the top right side. So this is formed in a 3D printed bed platform. So this is the stereolithographic apparatus in which there is a platform and a laser source. And this laser source emits UV light in order to cure the resin used in the 3D printer. This UV curable resin is a thermoset plastic, whereas in FDM technology, the material used is thermoplastic. In SLA 3D printer, the resin used is thermoset plastic. So any material which is formed out of the SLA 3D printer cannot be reused, cannot be remelted and reused. Whereas in FDM technology, it can be remelted and reused since it's a thermoplastic. So let's go into the working principle of the SLA technology. So this laser source, yellow in color, this yellow based UV based laser source emits UV light, and the XY scanning mirror reflects this UV light into the resin tank. This resin tank is filled with resin, thermoset resin, and the platform just adjusts the height as per the layer height of the component. Typically, the layer height achievable in a SLA 3D printer is from 25 microns to 100 microns, which is 0.025 mm to 0.1 mm. So this is the maximum and minimum layer height which is achievable in the SLA machine. So in this technology, as this platform moves from the upside to downward direction, that is the top and bottom approach, top to bottom approach. So in SLA machine, the machines using top to bottom approach, the laser light cues the resin and forms the first layer, and then the second layer and third layer. So once we input the STL file into the slicing software, it converts into different slices. Like the slice thickness will be equal to the layer thickness, and the SLA machine produces the 3D printed part using the laser source. Whereas in DLP technique, a digital light projector is used beneath the resin tank, so that the light is projected, that is the cross section or the contour of the 3D printed part is projected into the platform. So the light cues the material used, that is resin, which is a thermoset material, and the final product is obtained. So the difference is, in SLA they are using a laser source, and in DLP a digital light projector is being used. So this is a LCD SLA 3D printer. This combines the benefits of SLA and DLP techniques. So here they are using a LED screen from which a light, UV light, is projected from the LED screen, and photopolymerization happens in the chamber. So this is bottom up approach. The platform is in the upper side and it moves from down to up. So it's called bottom up approach. So almost all the commercial machines, that is low cost machines available, they'll be using going for bottom up approach, like the one used in SLA 3D printer, SLA LCD 3D printer, and the DLP 3D printer. Whereas in basic SLA machine, the technique used is top bottom approach. So the build platform moves from top to bottom. So in this, the print parameters are already fixed by the manufacturer, and we can change only a few of the 3D printing parameters available. And the layer height can be changed, and the layer height can be changed from 25 microns to 100 microns. In terms of support, these are the support materials available in a SLA 3D printer. So these supports are very much mandatory for a SLA 3D printer to print the components in a good form. So the component placed will be in a 45-degree angle in order to reduce the cross section of the printing component, so that you can easily remove the 3D printed part from the build plate. And these support materials are tree-like support materials, which has a point contact with the 3D printed base part. And this can be easily cut away using a plier. So it is very easy to produce a SLA SLA 3D printed part at high accuracy and with high dimensional accuracy and high detail and high finish. So once the 3D printed part is obtained out of a 3D printed SLA 3D printer, this part can be further cured by keeping it into a UV chamber, or you can keep it in the sunlight to enhance the mechanical properties of the material. So once you keep it in the UV chamber or sunlight, it absorbs UV rays and it starts hardening. Like the tensile strength and hardness, everything gets higher in nature. So once you do the post processing, here the post processing technique is keeping it in a UV chamber or sunlight. And similar to FDM technology, in FDM there is a defect called warping, which is caused due to the underlying layer, and here it's called curling. Once the resin starts curing the resin starts cured by the UV light, the material shrinks and it creates internal stresses and makes the object curled, like similar to the warping in FDM. And the coming to the layer adhesion between layers is very much highly bonded, and it is very high in case of SLA 3D printer because it is made of liquid, whereas in FDM it is of plastic, molten thermoplastic. So both are different. In FDM the layer adhesion will be very low, and in SLA the layer adhesion is very high. So coming to the materials used in SLA 3D printer, there are different materials which are used in SLA 3D printer. These are the types of resins available. First one is the normal resin, which is normal thermoset resin, which is cured at 405 nm wavelength of UV light. And then comes the castable resin, which can be used in making dyes or molds. And then comes the dental resin, which is biocompatible in nature, and it can be used for dental purposes. And then comes the flexible resin, which where we can use it for prototyping purposes. And then the transparent resin. This transparent resin, we can print it in a SLA 3D printer, and by finishing it properly, you can we can get a fully transparent 3D printed component. The last one is the tough resin, which has few ABS and polycarbonate traces in the resin material, so that it can have high strength and hardness. So coming to the pros of SLA technology, this is one of the most precise 3D printing technique, and it can reach high quality and high detail features can be 3D printed using a SLA 3D printer. And the microns in terms of layer height, as low as 25 microns can be attained using a SLA 3D printer. And the dimensional tolerance is also very high in case of SLA 3D printer. Only thing is the maintenance should be made every day so that the 3D printer is holding its tolerance and accuracy. The print surface is smooth, and build volumes can be very high, like it can go up to 1 meters for a SLA 3D printer. The demerits of SLA technology is the printing time is very high when compared to FDM technology. There are many support structures which is required using SLA technique. So there are many issues of failures which is being faced in the SLA technology. Nowadays, researchers are going on to reduce the failures which is faced in the SLA technology. And these resins are not very good in nature. They are toxic, and we need to protect ourselves when working with the SLA resins. And the material availability also is also very less, and the material color choice is also very less. So when compared with FDM, the SLA holds down in terms of material and its color. And the SLA printing cost is also very high when compared with FDM technology. So next 3D printing technique is powder bed fusion, which is the polymers. Polymer powders are being used, and this technology is called SLS, selective laser sintering. So this powder fusion technology, it has a feeder piston, and the left side is a feeder piston, and this is a supply feeder piston. So in both sides of the build plate is the feeder piston, and the build plate will be in the top at the start of the print. Once the leveling roller rolls the material over the build plate, a thin layer of powder will be suspended over the build plate. Then in SLS technology, the laser used is a CO2 laser or any similar kind of laser, where this SLS nylon material is being sintered using the laser beam, which is focused using the lenses and scanning mirror. So as you see, this will be a SLS printed part in the downside of the slide. So this is the working principle. Basically, the powder is rolled by the roller and the laser sinters it layer by layer as the delivery piston, the platform moves downwards. So this is the SLS 3D printer where the Z direction is moving downwards and the recoater or the roller will be in the one side of the machine and it coats the raw material over the build platform, and the laser starts building the sintering the component. So there are wide range of materials used in SLS technology. They are very strength and functional parts can be made out of a SLS technology. So the base material used is thermoplastic powder, and it is still in the industrial scale. And commercial machines are very less in case of SLS technology. So when we come to the characteristics of SLS technology, in SLS technology, almost all process parameters are preset by the machine manufacturer. The default layer height used in SLS is 100 to 120 microns roughly. The key advantage of SLS is that it needs no support at all, since the powder itself acts as the support structure required. In SLA and FDM techniques, there is a separate support structure which needs to be formed to support the overhangs, whereas in SLS technique, the powder by itself acts as a support structure. So taking advantage of the whole build volume is which is very important when printing in SLS, especially for small batch productions. So a bin of given height will take the same time to print independent of number of parts it contains. So independent of the number of parts placed in the 3D printing software, the total bill plate should be covered with products in order to attain a good optimized printing estimation. So the in the using the SLS 3D printing technique, you can go for low volume productions. That is parts which require very less volume and which is mass customized can be printed out of a SLS 3D printer. So in SLS 3D printer, the bond strength between layers is very excellent, and it means that SLS printed parts have almost isotropic mechanical properties. The main material used here is nylon and has a tensile strength of about 48 megapascal, and it is in the XY direction, whereas in the Z direction it will be little lower, which is 42 MPa. So these SLS parts have excellent tensile strength and modulus comparable to the bulk material, which are more brittle, and this is due to the internal porosity of the final part. Since it uses powders and the laser sinters the component, uh, the porous nature is very high in case of SLS 3D printed parts. Typically, SLS 3D printed part is about 30% porous. So this porosity gives SLS parts their characteristic grainy surface finish. The surface finish will be almost grainy, not in terms of layer lines. It will be like a dotted surface finish. This also means that SLS parts can absorb water easily, so that they can be easily color dyed in hot bath. As per our selection of color, we can dye the final SLS 3D printed part easily. And in a humid environment, special post processing is required for SLS part. The main disadvantage in SLS is the shrinkage, warping, and over sintering of the material. So in FDM and SLA, there is warping and curling. Similarly, in SLS parts, it's susceptible to shrinkage and warping. As the newly sintered layer cools, its dimension decrease and internal stresses build up, pulling the underlying layer upwards, similar to the FDM and SLA techniques. Once the layer starts cooling, it pulls the previous layer so that shrinkage and warping could occur. Um, let's come into over-sintering. Over-sintering is the process where the temperature reaches beyond the melting point of the or the sintering point of the material used in the SLS 3D printer, where the laser sinters the material over the temperature required. So this makes the 3D printed part to lose its structure. So, for example, a 0.5 mm wide slot or a hole with 1 mm diameter will successfully print on 2 mm thick wall. But whereas if we keep a wall thickness as 4 mm and in order to print a 0.5 mm wide or a 1 mm diameter hole, it will not print successfully in SLS 3D printer. So these kind of design characteristics have to be studied before entering into the SLS technology. So since SLS requires no support material, parts with hollow sections can be printed easily and accurately. These hollow sections reduce weight and cost of the part as less material is used. So you can see if a hollow structure is being 3D printed in a SLS 3D printer, the the powder can be encapsulated inside the 3D prints, which should be taken out using escape holes. The parts will be given escape holes of about 5 mm diameter, where the raw material can be extracted out of the 3D printed part in case it's getting encapsulated inside it. So these kind of design changes should be given in the start of the SLS 3D printing. So these are the materials used in SLS: polyamide PA12 and the other polyamide PA11, peak material. And these polyamide powders can also be mixed with certain additives, carbon fiber, glass fiber, aluminum. Even aluminum can be mixed with polyamide powders to improve the brittleness and can have highly anisotropic behavior. So coming to the advantages of SLS technology, it has a good surface finish and it is of we can develop highly functional prototypes out of a SLS 3D printer. The disadvantage is it's bit costly and usage of powder, wastage of raw materials is very high in case of SLS materials if it is over-sintered. So next, let's see about the material jetting or DOD technique. So material jetting 3D printing. So this component is a material jetted 3D printed component. This is a transparent part which is shown here. And in this, the material is jetted, inputted from a resin tank, and the material is jetted through various nozzles, like thousands of nozzles will be available in the extrusion head. And this nozzle lays the build material and the support material or a mixture of it so that it lays layer by layer, and a UV light is provided just adjacent to the nozzle, so that once the layer is deposited, once the resin or material is jetted into the bed, the UV light cures the material. So this is the material jetting process, which is also called polyjet technology. So this is a material container where the material is available. 2 kinds of materials or 4 kinds of material can be loaded into the material container. And these tubes carry the material into the print head. So this print head has inkjet print head, like different many numerous nozzles are available in the print head, and this print head prints one by one layer above the layer, and then the final part is obtained. And in the right side is the UV curing light, which cures the 3D printed part once the layer is formed. So, coming to the characteristics of material jetting. The main advantage of material jetting is it can use multi-materials, and full color printing is also available in material jetting 3D printing. So in this, the printing parameters, all the printing parameters are preset by the machine manufacturer, and it is available in their software. And even the layer height is very much specified by the manufacturer, and the typical layer height used in material jetting is around 16 to 32 microns, which is very highly reachable layer resolution comparing the other technologies. So in material jetting 3D printing, you can reach higher layer heights, like 16 to 32 microns is very intrinsic, and very intrinsic parts can also be 3D printed using a material jetting 3D printer. Material jetting is considered one of the most accurate 3D printing technologies and has a dimensional accuracy of about plus or minus 0.1 mm. Sometimes smaller parts can have a dimensional accuracy of around plus or minus 0.02 mm. So which is very much similar to the designed component. So warping can also occur in this technology, such as like warping in FDM and curling in SLA, because printing happens at near room temperature, and the typical build size will be around 1 meter cross 800 centimeter mm cross 500 mm. So even lower build size machines are also available in material jetting 3D printer. So when we go into the multi-material 3D printing, so this is the ability of the 3D printer to produce accurate multi-material or multi-color prints that represent the end products. So this can be developed in 3 different levels. One is the build area level, that is different parts can be printed in different materials or colors simultaneously, speeding up the manufacturing process. And one is at the part level. Different sections of a part can be designated to printed in different material or different color. As you see in the image, you can see a remote which is a plastic component with having flexible or soft buttons. So this is out of a single 3D printed material jetting 3D printer. So the flexible parts are being evolved using mixture of uh, the printing materials used. Basically, PolyJet uses 2 materials. One is the Vero and the other one is the Tango material. So by the Tango material is kind of flexible, and the Vero material is a bit hard, tough in nature. So mixing these 2 materials using the nozzles in the printing head, the final component can be obtained where the single component has both the strong material as well as the flexible material. So in terms of research, it is the best machine which can be used for many different research purposes, for making insoles, for making other orthotic braces. This material jetting can be used, which is very helpful for replicating the end product as a single product. So next is the dissolvable material printing. So in this technology, the support structures are produced, and there is a separate material which is called support material in the material jetting 3D printer. And these support materials can be dissolved or using air pressure or water pressure out of a high velocity nozzle. You can clean the support structures easily. And there are 2 finishes available in material jetting technology. One is the matte finish and the other one is the glossy finish. When you see the image, you can see one is the right side is the matte finish and the left side is the glossy finish. So you can ask, what is the difference between matte and glossy finish? So when we give the material setting in the 3D printing software as matte finish, almost all the structures which is in the overhang gets the support material, and hence the finish comes as a matte material. So generally matte material, when printing in matte material, the cost involved is very high because the support involved is very high, whereas in for glossy finish the support involved is very less, and only places which has a overhang gets the support material. So the other parts will be looking as a glossy finish. So this is the difference between matte and glossy finish in a material jetting 3D printer. So these are the materials used in polyjet or material jetting 3D printers. One is the standard flexible simulated polypropylene PP material, simulated ABS material, castable material, high temperature material, transparent, and medical grade materials are also available in material jetting 3D printer. So each one has its own advantage and disadvantage. Like the standard material which is used in this material jetting is just for prototyping purpose and simulates the injection molded parts, but it's very brittle in nature. Almost all the materials used in material jetting is brittle in nature, and few based on the applications of the 3D printed part, the material should be chosen. Coming to the benefits and limitations of material jetting technology, this can, as you see, this can produce smooth parts which has high dimensional accuracy. We can reach dimensional accuracy of about plus or minus, even plus or minus 0.02 mm is reachable using a material jetting, which is not available in any other 3D printing technologies. So parts created with material jetting have homogeneous mechanical and thermal properties. Since it's inputted from different nozzles, it has a homogeneous mechanical and thermal properties. And many multi-material capabilities has a big advantage in the material jetting 3D printer. Using the multi-material capabilities, you can carry out various researches, which is being carried out right now all over the world. And the main limitation is that material jetted parts are mainly suitable for non-functional prototypes as they have poor mechanical properties. Only certain occasions that we can use it for functional prototypes, and the other things for a high impact load or something like that, you cannot use the material jetted parts. And these are photosensitive and very toxic in nature. So in controlled environments, you should be 3D printing this material jetted parts. You should have an exhaust fan, and proper throwing away of material should be handled during the 3D printing 3D printing process. So next one is the binder jetting technology. So this is almost similar to the SLS technology, where the material used here is powder, and the instead of laser in SLS technology, they are using binders which travels through the nozzle head. So this binder binds the material one layer over the other. So basically the working principle of every 3D printer is the same. The technology or the materials used will be the difference. So in this, as you see in the image, you will have metal powder which is suspended in the bin, and a roller rolls the powder, metal powder, sand, anything can be used in the binder jetting 3D printing technology. And this metal powder, when rolled over the build platform, the binder is being applied as per the contour of the or cross section of the 3D printed component, so that the final 3D printed output is obtained. So here you can see the machine, how the binder jetting process takes place. You will have inkjet print heads which is connected to the material container where the binder material is stored, and it gets deposited onto the build platform. The build platform moves upward to downward into the downward direction. So once the powder bed is filled with the material, the recoater, this is the black recoater, it coats the material over the powder bed, and the binder is being applied through the nozzles, inkjet print heads, and the final product is obtained. Here, the support structures are not at all required because, as in SLS technology, support structures are not required in this process, where the powder itself acts as the support structures for the build component. So instead of this binders used in the inkjet printheads, it also uses color CMYK colors in order to give a texture or give a full color printing output. So the print heads uses binders and other CMYK color to get a full color 3D printed component out of a binder material jetting 3D printer. The layer height varies from say 50 microns to 100 microns, and it is very much used in sand casting and making of molds. Like even bigger, larger area 3D printers are available in material jetting, where it uses sandstone material as the or sand material as the gypsum material as the printing material, where you can produce huge components which can be used for making molds. And once the materials are 3D printed using the material jetting process, it involves very less post-processing technique. In case of sand casting cores and molds produced from a material jetting process, you can see the image which is shown here. This is a sand casted core and mold, which is printed out of a material jetting 3D printer. This requires no post-processing at all. There is no support structures which is developed during the material jetting process, and hence the post-processing required is very, very less. Whereas you can also use metal powders to be used in material jetting process. You can think like, how can a metal powder be binded together and then formed a 3D printed component. So in this, it is a low cost solution for a metal printing object. In this, the metal powder is suspended in the bin, and layer by layer the metal powder is being binded using the jetting process, and then it is infiltrated or sintered in the furnace so that the binder material flows away. Around 60% or 50% of the printed component will be of binding material, which will be blown away during the sintering process or keeping it in a furnace for a higher temperature, where the binding material flows out of the printed part, and then the printed part will be infiltrated with the brass material or bronze material, so that the final 3D printed part will be very strong in nature, whereas the other sand casting cores and molds will not be very much strong, and it has its own disadvantage. So these are the materials used in binder jetting processes. First one is the full color sandstone material, which where we can you would have seen in the online platforms, where you can see your sculptures being made in full color 3D printed components. So they will be scanning yourself, and the final output will be of VRML or OBJ file, where the color texture of your face or your image will be transferred onto the structure of your human body, so that full color can be obtained using a binder jet 3D printer. Then the material used is silica stand, where very high thermal resistance is a big advantage, and it's excellent for sand casting applications. As I said, this is a sand casted core, which is shown in the bottom image. Next is the stainless steel metal printing component, which has good mechanical properties, and it can be machined. As I told, bronze can be infiltrated into the stainless steel component so as to increase the mechanical properties. So enhance the mechanical properties. And the disadvantage is it's 10% internal porosity. There can be many voids which can be obtained during the 3D printing process. After the 3D printing process, when it is the binder is being blown out of the 3D printed part. So next one is the stainless steel, which is being sintered. So in this, it has good mechanical properties and is of high corrosion resistance. And there is a little bit of internal porosity even after sintering of the stainless steel. Next is the incolon alloy, and it has all the major advantages in the 3D printed component. Even tungsten carbide are also used in the binder jetting process. So benefits of binder jetting is that it can compared to when we come to binder jetting process, we cannot compare it with FDM, SLA or SLS techniques. It should be compared with DMLS or SLM technique, which is being explained in the next slides. And when we compare it, it is just a fraction of the cost when compared to DMLS. If DMLS cost you 1 lakh for a component, this binder jetting will cost you around only around 60,000 or 50,000, because material wastage in binder jetting technology is very less, because the support material formed in DMLS is very high when compared to binder jetting process. In binder jetting, there is no formation of support structures, hence eliminating the support structures. So the cost is also very much reduced. And in binder jetting process, very large complex metal geometries can be produced using the binder jetting 3D printer. And it's also excellent for low batch production. Low volume production can be carried out using a binder jetting 3D printer. So the limitations are, it has lower mechanical properties. A unsintered or a unfiltrated part will have lower mechanical properties, and which is the output of the binder jetting 3D printer. When compared to DMLS or SLM parts, it is of very lower mechanical properties. So we should be enhancing the mechanical properties using sintering on infiltration techniques when the product is taken out of a binder jetting 3D printer. And only rough details can be printed in a binder jetting printer, and it is in the green state, like it is very raw in nature and may fracture during post processing. So high care should be taken when we are post processing a binder jetted part. So the material selection is also very much limited in terms of the material provided. Third-party materials cannot be used in 3D printer, which is a big disadvantage in binder jetting 3D printing process. So the last one is powder bed fusion metals. So as in SLS, you are using polymers in the powder bed as the powder or as the raw material. Whereas in the last topic, we are going to use metals in the metals as the raw material. So it is of 3 types. One is the DMLS type, and SLM and EBM. DMLS is direct metal laser sintering. SLM is selective laser melting. EBM is electron beam melting. These 3 are almost the same. The technology working principle is almost the same, whereas the material used is different. Like the material used in all these components all these technologies will be different. We can see it in the later slides. So this is the 3D printing working principle of a DMLS or a SLM technology. You have a high frequency or high powered laser, which is basically CO2 laser or any other electron beam or anything, which is used. This machine will be used in a controlled environment, and inert gas such as argon will be inputted into the 3D printer machine so as to not to oxidize the metals available in the printer. So it is similar to the SLS technology where the powder bed roller rolls the powder onto the build platform, and the laser melts the powder so that the final component is being produced. Below shown is the different 3D printed metal components which is made out of a SLM or DMLS 3D printer. You can ask when can I go for a DMLS or a SLM or EBM 3D printed component? So one with uh, difficult or intrinsic or complex geometry, you can go for metal 3D printing. Otherwise, you can go for conventional manufacturing process because the cost involved in DMLS and SLM is very high, and the material availability is also very less in case of DMLS and SLM techniques. So this is the DMLS process which was being explained in the before slide. You will have a recoater as in the SLS technique. This recoater coats the build platform with the metal powder, and the laser system scans and heats the sinters the melts the metal powder which is available in the build platform. And there is a overflow bin to capture the extra amount of powder which is being coated over the build platform. So main characteristics of metal 3D printing is it's small batch. It can be used in small batch manufacturing. The one of the main important property is that you should fill the 3D printing build platform with materials so that the process gets economical. For printing just one or two components is not economical in a DMLS or SLM 3D printer. You should fill with many components in the build platform so that the 3D printed component taken out of a SLM or DMLS printer will be economical, comparatively lower in cost using this technique. And the powders used is highly recyclable in nature. The dimensional accuracy is around 0.1 mm, and the layer height achieved is around 50 microns to 100 microns. And hollow sections and lightweight structures can also be 3D printed using a metal printer. You can see there are two techniques, which is DMLS and SLM. There is a big difference between DMLS technology and SLM technology. This SLM technology uses single material, homogeneous material is used as the raw material. Whereas in DMLS technique, there are two or three materials of different melting point, melting temperature used in the 3D printer. So this is the main difference between the DMLS technique and SLM technique. Whereas in EBM, many high-grade materials can also be used. So you can see the 3D printed part here, small 3D printed parts where the total build platform is being filled. Only then the economical process happens, and this is the support structures produced out of a metal 3D printer. These support structures are produced from the bottom platform so as to easily remove the 3D printed part after 3D printing. There are many materials which is being used in SLM or DMLS 3D printer. These are the materials used: aluminum alloys, stainless steel or tool steel, titanium can be used, cobalt, chromium superalloys can be used, nickel superalloy, and precious metals such as gold, silver can also be used in this metal 3D printer. And you can see there are various alloys used in a metal 3D printer. So only these alloys can be 3D printed using DMLS technique and not in a SLM 3D printer. SLM 3D printer can only process single homogeneous material which has single material melting point. So coming to the benefits and limitations, the benefits of metal 3D printing is it can be used to manufacture complex geometries that traditional manufacturing methods are unable to produce. That is the point which I projected in the first when I started the metal 3D printing session. So this is very much important that only parts which has complex and which cannot be machined using CNCs or anything should be metal 3D printed. Other printing process can be also be used before coming into the metal 3D printing process. And the process optimization is very much important to reduce the cost or minimize the weight involved in the 3D printed component. Even when designing, you can use hollow sections to reduce the weight, because the material used amount of material used reflects the cost of the 3D printed component. So reducing the weight will reduce the cost of the printed component. And it have excellent physical properties when compared to binder jetting, metal binder jet technology. And there are huge range of materials available, and even metal super alloys can be 3D printed using a DMLS technique. There are certain limitations for the technology. The material and manufacturing costs connected with the 3D printing is very high. So this is not used for basic purposes. Only people who are going for a research or a research organization, kind of space research organization, can use these techniques to find out various complex geometries out, to make complex geometries out of a 3D printer, metal 3D printer. The build size is very much limited, and the manufacturing conditions or the environmental conditions should be in a controlled environment. So it is one of the limitation of metal printing. And existing designs cannot be 3D printed in a metal 3D printing, and it needs to be altered according to the 3D printing process available. So these are the limitations of metal 3D printing technology. So these are the technologies basically available in the market, and there are also other 3D printing technologies which are available, like LOM and other the LOM techniques is like you can build a component in full color method, and the laser cuts the contour of the component. You can use paper as well as the raw material for a LOM technique. Even cardboards are being also used for a LOM technique. And there are many accessories which aid the 3D printing technologies, which is a vast process. You can search in the internet for very mostly the bio printers and construction 3D printers which are being evolved in the recent years. So thank you for the opportunity given, and hope you had a glimpse of the 3D printing technologies available, because there are many 3D printing technologies. I should fasten up the speaking. So hope you enjoyed the session. And you can follow us at Instagram at insta3d_technologies, and you can review us on Google by searching for Insta3D Technologies Coimbatore. This is my contact number. You can even contact me for any queries or any doubts. Thank you. Hello. Hello. Any doubts or any feedbacks?
Hello.
Yes, sir.
Sir, my name is Vinay S. Marwal, and I am from Jaipur. And I want to ask you, my question is that you just presented one 3D printing process, PolyJet.
Yes, yes.
Now the thing is, in which form what are the materials which are available in for PolyJet, and second, in which form they will be, either in liquid form or in powder form?
It will be in liquid form. It will be similar to the resins available in the market. It is made up of polycarbonate or ABS-like resins, thermoplastic resins, and these liquid form material will be jetted into the 3D printer, and UV light will be used for curing this process. And the materials available is of two types. One is a strong material, and the other one is a flexible material. And the strong material is called Vero Clear or Vero Black material, and the flexible material is the Tango material, which is flexible in nature. You can mix these two materials in proportion so that you can get you can vary shore hardness of the material printed. Like if you need 85A shore hardness, you can mix a bit of Tango material and a Vero material. So the mixing is happening in the 3D printer automatically, and we need not mention the mixing proportion. It has the preset value where we can choose the shore hardness of the component being 3D printed.
Okay, according to hardness, it will mix itself.
Yes. It has many nozzles in the print head. So according to the hardness we input into the slicing software, the material gets mixed up and the output is getting produced. Like I showed you a remote pick, right? So in that there are flexible buttons which are being printed in a firm case.
And they are of only two colors. One is black and another one is clear.
Yeah. It is of only two colors. Like the flexible one will be of black color. But when mixing, the color can vary. The basic color of the resins can vary, and wide variety of colors is not available in polyjet technology.
Okay. Thank you, sir. Thank you very much.
Yeah, thank you. Any other queries? Thank you for the messages. Thank you, everyone. So, any other queries? So, Manisa?
Hello, sir.
Yeah, hello, sir.
Hello, sir. Please, sir.
Okay, sir. Yeah. We can wind up the session.
Okay, sir. Sir, session முடிஞ்சீங்களா?
Yeah, முடிஞ்சிச்சுங்க சார், முடிஞ்சிச்சுங்க.
Okay, sir. If you have any queries, any doubt to clarify the queries set out. Dear participant, if you ask any type of question means now.
Good afternoon,
Hello?
sir.
Yeah,
Am I audible?
Audible, sir.
Yeah, yes, sir. Sir, since we are talking about this 3D printing and then
sorry, sir, it's not audible.
So sorry. Am I audible now?
Yeah, yes, sir. Now audible.
Yes. Since it is like almost 20 years, I think this is we are talking about this 3D printing technology, right?
Yes.
So if I'm right, yes. Okay. So still, it is something which is not in our hands. So people are talking in terms of crores.
Yes.
If I would like to have a 3D printer, so which is capable of printing something a nice product,
Okay.
since it is not in under my hands, right? Even a university who is having a very good research facility, they couldn't able to afford it.
Yes.
Right. So
why is the reason? You are asking about the reason for not accessibility of 3D printing, right?
Yes.
Okay.
Basically, I have
Yeah,
trying to ask that.
Yeah, I will try to answer the question. Like the 3D printers which were developed in 1980s had a patent which was around 20 years patent, and the patent broke around in 2007, and from then the FDM 3D printers came into existence, and it is being used widely overall in the world overall. Like thermoplastics can be produced out of a FDM 3D printer, whereas SLA technology patent has also been broken, and it is also getting commercialized nowadays, where you can just spend around 50,000 to get a SLA 3D printer. Not a very big 3D printer, a small 3D printer. Even you can use your cell phone to 3D print components. There is one printer called Ono 3D. It's manufactured by the US, and it uses your cell phone to 3D print the components. So actually, the machines are available, and we are not getting used to it. Like it is getting evolved in other countries. In India, only the FDM and SLA techniques are getting evolved very much, and it's very much accessible. Whereas these SLM and DMLS techniques are found by big players like Stratasys 3D systems, and they have a patented technology for with them, and it has not been commercialized. And DIY machines are not being produced in the SLM or DMLS technologies, SLS technologies. So the cost is a bit high. When you see the metal printers cost, you should at least invest for around 1 crore rupees in order to get a metal 3D printer. So everyone is using the technology like FDM, SLA nowadays. That's the main reason behind it. Like the patent and the working principle, or there is some trade secret kept behind the SLM or DMLS 3D printers.
Thank you. Thank you for the information.
Thank you.
Any other, sir? Any other? Any other question, sir? Okay, sir. It is very useful for our participant and other things. Very nice, sir. Very nice
Thank you.
presentation. Dear
Have a nice day,
participant.
everyone. Yeah.
Yes, yes, sir. Participant, if you ask any type
So
of
shall we
question,
wind up, sir?
participant, if you ask any type of questions now, anything? Okay, thank you, sir. Thank you for your valuable and nice session. Wonderful one, sir. Thank you. Thank you.
Thank you. Thank you.
Thank you.
Yeah. Thank you.
Wait a minute. Next section
Yeah,
start
yeah.
at 2 p.m. sharply to handle session number 9. Dr. Prakash Kumar Satyabama, Professor Satyabama Engineering College, Chennai. Exactly 2 p.m. to start this session. So all the participants requested to fill the feedback each in every session. Before that, all of you send it. For current session, all of you fill the feedback form and submit it here. So now it's to unmute your video to take photos. Photo session. Okay, sir. Okay, thank you. Thank you. Thank you. Thank you for